Alright, hi year 11s, this is Mr. Lim here again, and this is another video on gases. This time we're going to deal with Boyle's law. So let's get started. Okay, so we're going to be learning how to describe Boyle's law and how volume and pressure change in a container. Alright, so what is Boyle's law? So let's have a look. Boyle's law is the relationship between the interior pressure and the volume for rigid containers with variable volumes. Okay, so what are rigid containers with variable volumes? Generally, they are some certain containers, and there's generally some sort of plunger here, right? So this plunger is some sort of solid metal, and the outside is also some solid metal or something like that. All right, and then this plunger moves up or down depending on what you want it to do, and so therefore it's a rigid container because all the walls are rigid, but it has variable volume because you can move this plunger up and down. Okay, and thus then the relationship, what is it? The pressure and the volume have an inversely proportional relationship, which means that they, as one goes up, the other one goes down. Right. Okay, let's go on. Okay, so decreasing the volume. So let's go through an example. Decreasing the volume of a rigid container will cause an increase in the internal pressure, and why? So let's go through why. Okay, so decreasing the volume of the container effectively reduces the distance between the walls of the container. Okay, so here we have that exact same sample where the distance between the walls are from here to here. All right, and now with the new plunger in its new position, the distance between the walls is here and here. Okay, so it reduces the distance between the walls. Since the particles are moving at the same speed, but because they're at the same temperature, with the decreased distance between walls, they will collide with the walls of the container more frequently. Okay, so simply because the walls are closer means that they collide more frequently. Now this diagram here isn't the best, because here's like one arrow line and here's another arrow line, and this second arrow line is much larger. I think it's trying to show the idea that it can collide more often, but the point is that these arrow lines should really be the same distance or the same length because they are at the same temperature. All right, so Boyle's law is in effect for all systems when they're kept at the same temperature. Right, so the idea is that because the walls of the container are closer, the collisions will occur more frequently, and therefore the more frequent collisions leads to an increase in the pressure. All right, so the relationship between pressure and volume is not a linear relationship. Okay, so because if it was a linear relationship, there would have to be a way where there is zero volume or zero pressure, and those things can't exist. Okay, so if you think about it, right, if I have my plunger here and I bring the plunger right down to the bottom, I should in theory be able to get it to have zero volume. Okay, but the idea is that, there are still gas particles in here, and when you compress these gas particles enough, right, when you compress them to the point where they have to be next to each other, they are going to effectively turn into a liquid, right? So you can liquefy something by compressing it hard enough, right? When you compress it hard enough, you effectively make them go right next to each other. And again, this is the idea behind ideal and real gases, is that ideal gases would say that the space between, or the size of the particle, is negligible compared to the space between them. But a real gas, we know that if you compress them enough, they will eventually sit next to each other and turn into a liquid, and therefore their volume can't go to zero because liquids have a fixed volume. All right, so you can't have zero volume, nor can you have zero pressure. Okay, the opposite of this is when I make the volume as large as possible. Okay, so imagine if I bring this plunger all the way up to here, those particles now have a lot more room to move, right? But no matter, even if I was to infinitely bring that plunger up, there would still be collisions with the container walls, right? And so therefore the pressure can't be zero. All right, so therefore, since that is not a linear relationship, it's a hyperbolic curve, which is this curve here, right? Where the two values never reach zero on either axis. Okay, the idea is that when you squeeze them in, the pressure will going to get very high, but never reach infinity, and the volume will never get to zero, and vice versa. All right, so the idea is that it's a curve. It is not a straight line. If you want it to be a straight line, you have to graph pressure over pressure and 1 over V, all right, or V and 1 over P, right? So you could graph, you could graph 1 over V versus P, or you could graph V versus 1 over P, and then you could get a straight line, right? And that would be a straight line like that. But we don't, you can show it like that, and some people do, but not in this course here, so don't worry about that. Okay, so that's the idea there. That's Boyle's law, nice and short. Adios.